Welcome to Cloud Activate. This is a webinar from Claranet that we are going to do on a quarterly basis. This is the first session of this Cloud Activate sessions, and the topic for today is Azure DevOps. So I want to welcome you to the Cloud Activate session, and I want to explain you also the reasons why we decided to do this kind of webinars. First things first, what is the Cloud Activate about? First thing, you can rest assured that is not a sales session. So we are not trying to sell you nothing. Okay, so you guys are safe. Okay, we are not also trying to teach you anything. It's not a training session. Okay, so what we want to do is share and also learn some things that we learn through this process. So we use Azure DevOps for quite some time. We cannot say that we are the experts on the matter, but we think that we have some good insights on this kind of products and services that we want to share with you. And hopefully, for those of you that join us the session that also use Azure DevOps, we want also to learn with you. So we want to understand what you are doing today with Azure DevOps, and because you can also teach us something. And finally, we hope this session can help you, inspire you to achieve more. When we talk about DevOps, we talk about speed, automation, less risk, less failures, and this is all about that. So we want to help you. The intent for today is to show you Azure DevOps only, but to tell you how you can use that to speed your organization and help them achieve more value. Okay. So I'm going to present you your hosts for today. So I have here with me Nuno Cerro and Pedro Carvalho, which are our cloud architects. They are both specialized in Azure, and they will be doing the sessions for today. So we have a first part, which more introductory, and then we are going to do some demos where you can hopefully see how we are doing things. And then we go to a final part where we open discussion and want to understand what you are doing today, what was your thoughts on this session, and how we can improve it in the future. Just a final remark, during this webinar, we'll launch a quiz, and I sincerely hope that you can answer and be completely transparent and honest about what you think about this session today, because this is the only way where we can improve better for the next time. So with no more further ado, I'm going to give control to Pedro Carvalho. Pedro, can take it from here.
Okay, good morning, and thank you, Vasco. In the first part of this session, it's our goal to give you some insights into DevOps concepts. So let's start. Let's start with what? What is DevOps? This is the definition of DevOps you can find if you go to Wikipedia. DevOps is a set of practices that combine software development and IT operations. It aims to shorten the system's development life cycle and provides continuous delivery of high software quality. The highlighted portions in this definition might be some of the reasons that might lead you to start using DevOps. Shortened development life cycle and also continuous delivery of high quality software. The Microsoft's definition of DevOps, taken from Mr. Donovan Brown, focuses on the union of people, processes, and products, and then the continuous delivery of value. This nice representation of the DevOps lifecycle reinforces the continuous journey. You plan, code, build, test, release, deploy, operate, and monitor to get feedback and use that information to plan the next build. For AWS, DevOps is a combination of cultural philosophies, practices, and tools. in order to deliver applications and services at high velocity. In this diagram, they depict the life cycle with focus in two large pipelines, delivery and feedback loop. In delivery, you can see building, testing, and releasing, and in feedback, monitoring and planning. Guided by the previous definitions, we should therefore focus on people and practices and a set of tools. Let's start by talking about a needed organizational change. Organizations that work in silos often result on each team having different goals. As an example, the development team might be focused more on functionalities and in faster and more frequent deploys. And the operations team might be more focused in no downtime and making sure that deploys don't break things. An agile will have cross-functional teams to achieve faster deploys, more stable platforms, and improved efficiency through the use of better communication and collaboration. Leadership shows the direction and enables action, and everyone is accountable and works for the same goals. So in this approach, development, quality, operations, and security teams should be transformed into a single or multiple cross-functional teams. These teams share the same practices and tools and have as an end goal to provide better customer experience. These cross-functional teams should adopt the following practices. By planning and coding, they work towards continued development. By building and testing their code, they can achieve continuous integration. By assembling releases and deploying them to single or multiple environments, they perform continuous deployment. And by operating and monitoring each environment, they can provide continuous monitoring. Closing this loop and continuously repeating it, the full DevOps lifecycle and continuous feedback is achieved. Let's dive a little bit into each of these practices. With continuous development, we adopt agile planning and isolating work into smaller batches called sprints, and by managing the team's capacity and managing the flow, therefore helping teams quickly adapt to changing business needs. One interesting feature of agile planning is the definition of done, which in the context of DevOps is working software collecting telemetry against the intended business objectives. Please note that the easily forgotten part of business objectives. With continuous integration, automation, and specifically testing will allow you to find defects early, one very important benefit. In continuous deployment, we take care of deploying, which means the installation configuration of a release into single or multiple environments. By leveraging both CI and CD, you can achieve continuous delivery, but that means delivery on demand, but not necessarily 1,000 times a day. Finally, with continuous monitoring, health usage and logs are collected and analyzed to provide insights to feedback into the loop. Not mentioned before, but obviously missing so far in this presentation, is the practice of source control, meaning the practice of tracking and managing changes to code. This practice includes a repository of source code to effectively allow each team to collaborate, resolving conflicts by merging contributions from multiple developers. The source code is not in someone else's computer and protected against accidental deletion or corruption, but rather in a distributed or centralized repository. Any single edit can be tracked and rolled back if it causes problems. The de facto standard tool for source control is Git, the distributed version control system. If you use any other version control system, I advise you to switch to Git as soon as possible. If you don't know already, Git was developed by this gentleman over here, the father of the Linux operating system. Another recommended practice not mentioned so far in this presentation is infrastructure as code, or IAC. Infrastructure as code goes one step further by including infrastructure creation and teardown by using scripts. Since you are using code to create environments, you can also store this code in source control repositories and assign a version to your environments. This slide also enumerates several examples of scripting languages and tools you can use to help you achieve infrastructure as code. Tools like Terraform or tools like Azure CLI, PowerShell, Bash scripts, ARM templates, and AWS CLI, for instance. Just a quick overview of some other important definitions. Like shown in the previous slide, you can use scripts to achieve, for instance, infrastructure as code. Scripts can be declarative or imperative. In declarative scripts, you specify what you want to be created. In imperative scripts, you specify how, every single step that it is needed to create what you want. Another important concept is mutable infrastructure. Mutable infrastructure assumes you can install new software version into an environment just by reconfiguring it. If something goes wrong, you can end up with a corrupt installation or even a non-working environment.
Pedro, you're muted.
Sorry, I was in mute. Let me just start from this slide from the beginning. Okay. I was talking about declarative and imperative scripts. I believe everyone is hearing right now. Okay. So I was saying that declarative scripts, you specify what you want to be created. In imperative scripts, you specify how, every single step that is needed to create what you want. Also, another important concept is mutable infrastructure. Mutable infrastructure assumes you can install new software version into an environment just by reconfiguring it. If something goes wrong, you can end up with a corrupt installation or even a non-working environment. And you need to fix that before proceeding, perhaps by manually and doing some changes. There is no such thing as a rollback in mutable infrastructure. Immutable infrastructure assumes each new version is installed in a blank environment, built from scratch. Therefore, you can say that it's kind of ephemeral. In this case, if something goes wrong, you can just start from scratch with the previous version. When working with imperative scripting languages or command sets like PowerShell or Azure CLI, extra care must be taken with the concept of independency. This concept is derived from a mathematical background and basically states that if you run the same script several times and you always get the same result, then that script is independent. For example, when you have a script and use it to create a resource, you should check if the resource already exists, or your script can add more and more copies of the same resource each time it runs, or even failed, and therefore will not yield the same result. Let me introduce you to another concept, DevSecOps. For the adoption of DevSecOps, one should consider that security is everyone's responsibility and must be applied through all the lifecycle practices as a continuous process. Here are some examples of security-related activities that should be tightly coupled with the DevOps lifecycle. In planning and coding, the user authentication and authorization must be taken into account. You should also consider security best practices like the principle of least privilege or even multi-factor authentication. In coding, each developer should also follow security best practices. This usually requires some training. Claranet has a course entitled AppSec for Developers you can use to provide this training. In testing, Static code security testing or SAST tools like SonarQube, Veracode, Codacy, or Checkmarks can be used to provide early defect detection. Claranet also developed a SaaS tool called Code per Tool that is based on the Checkmarks engine. While deploying or even during operation, you should periodically run vulnerability scanners, like the OWASP's Z-Attack proxy, or even our own web AppSec. Regarding tools, let me share with you the periodic table of DevOps tools. This is a rather comprehensive list of tools in several color-coded DevOps-related fields. Fields like deployment, where you can see Azure DevOps pipelines, for instance, that is release pipelines, or AWS code deploy. In continuous integration field, you can see things like Azure DevOps pipelines, the build pipelines, or AWS code build. And of course, you can also see the famous GitHub in the source control management field. You can use this table to check for other tools like Jenkins, Maven, Ansible, Terraform, Chef, SonarQube, Selenium, JMeter, and many others. Let me quickly summarize some of the benefits of adopting DevOps practices and tools. Faster time to market, deploy more frequently. Quickly go from source code into production, but only with approved changes. Efficiency by maximizing the number of automated tasks. Minimize human errors and assure reliability and scripting everything. And security provided also by the adoption of DevSecOps, like explained in the previous slide. Finally, goal alignment and improve collaboration by using cross-functional teams, as explained before. By now, you're already very bored with all these DevOps concepts. So we all need a break to relax and hear an expert talk about this concept you will be hearing called speed.
Speed and power. Speed. Real speed. Rabbit speed. Raw, naked speed. Speeding. Speed and power. Loads of power. Yes. Feel the power of that. It's powerful. Speed is good for business. Speed. You know the top speed of a pigeon? Speed and power. A lot of power. Powerful. Monstrously powerful. Power. Speed and power. Speed makes you cleverer. Speed. More speed. Speed and power. I need power. More power. 100% power. A cathedral of power. Power, come on. Power. Speed and power. That's the solution.
So, is it all about speed? Well, almost. Sure, DevOps allows you to shorten your cycle time and deploy more frequently, but also allows you to decrease risk by automating more tasks and testing more and earlier, using pipelines to provide more consistency. Also, by gathering telemetry information, you can provide a fail-fast experimentation. But DevOps is not suited for every organization. Organizations with a startup mindset might obtain more value from DevOps than others. Sometimes the automate everything or script everything is simply not possible. Also, cross-functional teams approach might lead to some scaling problems in large organizations. In some organizations, the speed improvements might need to be taken at the cost of loosening some safety requirements. Also, constrained environments are not usually suited for automated deployments. And last but not least, containerized microservices applications might benefit more with the adoption of DevOps practices than monolithic legacy applications. Those of you who work in organizations that do not develop software might be wondering, well, this DevOps thing is only for software houses. We at Claranet at least recommend you that you investigate continuous deployment in order to obtain consistent automated deployment and take advantage of the pipeline's approval mechanisms to ensure that only approved changes get into production. Also, there might be a cost saving if you adopt immutable infrastructure approaches like the like the automatic creation of Q&A and test environments. You should also try to adopt continuous feedback practice by collecting telemetry and provide feedback to business to allow carefully planning of the next release. So at least investigate the benefits of these two practices, continuous deployment and continuous feedback. The other way to go is to rely on Claranet's experience as a managed service provider and embrace DevOps with our help. This slide shows on the right the stages of the DevOps pipeline, more or less related to the production environment or to the environments that are managed by the MSP. And on the left, the steps that are usually provided and usually the responsibility of our customers. So color-coded in this slide, you can see how Claranet can work with you in some areas and how we can fully take control of some other stages. Besides operating your environments, which is one of the MSP responsibilities, the operations part on the right of this slide, Claranet can also work with you on the left side of this slide and the development part again, if we can say so. Helping in continuous development and continuous integration practices by providing information and consulting in planning stage, for instance, or also by running and operating some automatic testing tools in the test stage. Software houses, of course, will still be responsible for the code and usually also build stages. Non-software houses usually outsource these two stages to third parties that return binaries for they to release into the environments, perhaps with Claranet collaboration. And this concludes my DevOps presentation. Thank you very much for attending. I will switch now to my colleague Nuno Cerro for a presentation about Microsoft Azure DevOps.
Hello, everyone. Thank you, Pedro. Following what Pedro talked before, in the second part, we will do an overview of the Azure DevOps services and the ways that you can take advantage of it. So first of all, DevOps on Azure consists on a broad ecosystem that includes a set of services and technologies and can integrate with your existing open source tools. For example, you can use Azure capabilities such as Azure Monitor, Key Vault, Security Center, and also third-party tools such as Terraform, Ansible, Chef, and Puppet. So all of these tools can coexist and be used together. The idea here is that you don't need to use only Azure services. In fact, you can leverage the usage of Azure DevOps, even if you are not using Azure for your environments. So Azure DevOps is a set of different services with different purposes that can be used alone or combined in a DevOps workflow. Let's go over the 5 main services that are part of Azure DevOps. So we have Azure Boards. Azure Boards provides you with a set of predefined work items to support tracking features, user stories, bugs, and tasks. It provides a visual interactive interface with built-in social tools for communication, and you can maintain a history of what the team decides on any particular work item. Azure Repos is a set of version control tools that you can use to manage your code. Whether your software is large or small, software project is large or small, using version control is definitely a best practice that we should all be using in our development cycle. It provides unlimited cloud-hosted private Git repos, and you can do collaborative pull requests and advanced file management. Azure Pipelines is a cloud service that you can use to automatically build and test your code, projects, and make it available to other users. Code combines continuous integration, CI, and continuous delivery, CD, to constantly and consistently test and build your code and ship it to any target. Azure Test software to ensure that you are shipping it with quality. It allows you to do planned manual testing, user acceptance testing, exploratory testing, and even get stakeholder feedback from users outside of your development team. Finally, we have Azure Artifacts. This tool allows you to create and share Maven, NPM, and NuGet package feeds from public and private sources with teams of any size. You can have fully integrated package management to your continuous integration and continuous delivery pipelines with this tool. Azure DevOps services span the full development lifecycle with full end-to-end traceability, high-scale, multi-region, on-premises, and cloud. Azure boards fully integrated with end-to-end traceability, Azure repos scalable to any team size and project size, pipelines with high availability, multi-region and hybrid cloud and on-premises targets, and test plans that helps you to ship with quality. Artifacts provides a consistent admin and access control. All of these used together provide an end-to-end solution for organizations looking for an enterprise-grade tool chain. As we talked before, Azure DevOps works with any type of application, on any platform, and any cloud. You can use them together with whatever tool or cloud provider you want, or even with the on-premises servers. It all depends on what you need. You can use Azure boards to plan, GitHub for your code, Azure pipelines for CI/CD, Artifactory for and then deploy using Ansible for AWS or GCP. Everything is possible using this tool. There are a lot of possibilities, so you can choose whatever configuration makes sense to you. So now let's do a quick overview of each of these services, starting with Azure boards. With Azure boards, you combine Kanban boards and drag and drop sprint planning with comprehensive traceability and reporting. It allows you to track your ideas at every development stage and keep your team aligned with the code changes linked directly to work items. You can use the built-in Scrum boards and planning tools to help your team run sprints, stand-ups, and planning meetings, and it also helps you gain new insights into the health of status of your project with analytics tools and dashboards widgets. Azure Repos allows you to collaborate on code changes with threaded discussion and continuous integration for each change. It works with your existing Git client, allowing you to securely connect with it and push code into your Git repos from any IDE, editor, or client. Repos has the capability of integrating with webhooks, APIs, and provides semantic code search, which gives us the ability to find what we are looking for with code-aware search that understands classes and variables. Azure Pipelines is the workhorse of Azure DevOps, actually. Automating your builds and deployments so you spend less time with the nuts and bolts of your project and be more consistent in your workflow. It works with any language, any platform, any cloud, and you can extend its functionality by using a wide range of community-built test and deployment tasks, along with hundreds of extensions from Slack to Sonar Cloud and others. It's a great tool to work with containers, allowing us to easily build and push images to container registries like Docker Hub, Azure Container Registry, or AWS. You can ensure fast continuous integration and continuous delivery pipelines for every open source project, and it gives you unlimited build minutes for all open source projects with parallel jobs across Linux, Mac OS, and Windows. With Azure Test Plans, you can get end-to-end traceability. You can run tests and log defects from your browser, track and access quality throughout your testing lifecycle. You can capture rich scenario data as you execute tests and make discoveries, defects actionable, and explore user stories without test cases or test steps. You can create test case directives from your exploratory test sessions. Azure Test Plans gives you the ability to test your application where it lives, complete scripted tests across desktop or web scenarios, and test on-premises applications from the cloud and vice versa. Azure Artifacts helps you collaborate on code changes with discussion and integration for each change. It allows you to get a universal artifact management for Maven, NPM, NuGet, and others. And with Artifacts, you can share packages and use built-in CI/CD versioning and testing, allowing you to easily share code across small teams and large enterprises. So as we saw in the first part of this webinar, where Pedro was talking about DevOps generally, monitoring is essential to have continuous improvement of your project. Azure Monitoring Solution provides a predefined solutions with smart thresholds and dashboards so you can get insights quickly and spend less time separating the signal from the noise and just accelerate your root cause analysis. You can also automate and integrate into your existing service desk platforms and as ServiceNow, for example. You can deploy repeatedly and reliably. Using external tools, you can deploy repeatedly and reliably using infrastructure as code. You can be using either ARM templates, Ansible, Chef, Terraform. So Azure Resource Manager provides these abilities from out of the box and works across Azure and other platforms. But if you're already using third-party solutions and tools such as Terraform, Ansible, Chef, Puppet, or SaltStack, Azure DevOps supports those tools too. You can extend what Azure DevOps is able to do. Extensions are simple add-ons that can be used to customize and extend your experience with Azure DevOps. There are over 500 extensions for Azure DevOps and Team Foundation services, covering all elements of the project lifecycle integrations with popular commercial and open source tooling. The marketplace is home to hundreds of tooling extensions that can be installed to help you with the following tasks, for example. Provide new pipeline tasks that teams can use in their builds, use dashboards widgets to get custom views with Azure DevOps, extend the work item form with new tabs, sections, and actions, create your own hub to embed new capabilities with agile code, build and test experience, and develop actions that can be run on hubs, whether they are ours or the ones that you created. You can also integrate with external tools, for example, SonarQube with continuous expression of code quality to perform automatic reviews with semantic analysis of code to detect bugs, codes, and security vulnerabilities. With the Azure DevOps framework on Azure, you can deliver continuous innovation faster. Azure DevOps provides a fully integrated set of enterprise DevOps services covering the entire DevOps lifecycle. You can use all of the Azure DevOps services or choose just what you need to complement your existing workflows. You can use, for instance, GitHub Enterprise or GitHub Business Cloud for the management of source code with direct integration into Azure pipelines to provide an end-to-end solution that leverages the power and familiarity of GitHub. If you already tooling choices such as Jenkins, Terraform, Ansible, or Chef, you can use them. If you made choices in some areas but you have gaps in others, you can take advantage of Azure pipelines to orchestrate and supplement your end-to-end DevOps toolchain. Regardless of your toolchain choice, you can take advantage of the reliable integrated security monitoring and managed capabilities of Azure DevOps. Okay, so we are done with the slides. Now we would like to show you what the complete setup of Azure DevOps looks like. And for this overview, we will use a tool called Azure DevOps Demo Generator to create a sample project that uses various aspects of Azure DevOps. So let's do this. Okay, so I have already a tab here opened on Azure DevOps Demo Generator. I'm going to choose a template to populate our DevOps organization with a project that uses several services that we talked before. So let's start with this. The project is called Parts Unlimited. Okay, so my session expired. Okay, let's do it again. Parts Unlimited, templates. So now the project is being created, and we expect that in our organization, we will have a new project called Parts Unlimited. So while this Azure DevOps Demo Generator is working and creating a populated project, I would like to talk a little bit about the some concepts of organization in a DevOps organization. So the organizational structure of DevOps, it can be used in several ways, but the start is that your company is using a tenant on Azure Active Directory, and then you can have several organizations for different purposes. And then within the organizations, you can create projects with each one having several repos, or you can even have more projects within the organization. So Azure DevOps organizations is just a mechanism for organizing and connecting groups of related objects, business divisions, regional divisions, and other enterprise structures. Let's see if this is already finished. Just wait a little bit more. So we see that the project is already showing up here. Let's just confirm if it's already finished. Not yet.
No. While the project is being created, you can show the Azure DevOps portal, the existing projects, and specify. You are already logged into an organization called Cloud PT, right?
Yeah. In our organization, projects that we created all the time, we are going to show you later on the demos. And so we can see the projects that are created in the organization, and you can navigate to each one of them. So I'm going to go through to Parts Unlimited because I think it was just maybe finishing it. Yes, it's done. So I'll try to do an overview using this project and starting by the summary. So on this page, okay, so my screen stopped working. Yeah. Sorry guys, I'm not seeing my screen here. It's expected. So sorry guys, we had a problem with our monitor, but it's expected on the live session, right? So these kind of things will happen. So starting with the overview of the Parts Unlimited projects. So you have in the summary, you can have a quick overview of the work items that are created on your boards and that work items. And if we even had some builds made on this project, we would see the completion rates of the builds and the deployment success. This is useful to get a really quick overview of the stats of your project. Now, going to dive into dashboards, it also provides you an overview of your work items and user stories and their progress along time. So right here, we can see that we have these user stories being worked on, and we can see also who are they assigned to and the progress along the time. So even though this project is generated, this is not completely populated, but you can have a feel of what you can see in this dashboard. For instance, we can see that we have a work item that's a critical bug and should be prioritized on working on. And you can see the user states, the user story states that it's a global statistic for each state of the user story. You also have the possibility of using a wiki. This project has some wiki parts already filled in, but the idea is that you can use this part of the wiki to document your project and help your developers getting started, for instance, how to set up their development environment and start right away using the project. So if you are using Azure DevOps, you can definitely put your information here on your project to help everyone get on board to the project. Now let's do a quick overview of the board. The first section is work items. Work items show you everything that you are working on and with different icons for the different kind of tests. So this one is a test, this one is an epic. So if you are familiarity with agile concepts, this is completely integrated and you can use work items in with this state. So here you could also see who it is assigned to, its current state. And then you can even drill down and see what the work item itself is in particular. So description, state, and you can start discussion right here with our other team members to see how this work item or task should evolve during the project. On the board section, we have what we would expect from an agile work methodology. So we have our new items that we are supposed to work on, but that are not really assigned yet. And we have two stages of the tasks that are being doing and when they are being done. So in this case, we also have this part with expedite. We want our developer to work on this item because it's a bug, it's a critical bug that should be solved as soon as possible. And so you can give it a priority here and change the severity of the work item so it can give further information to your developers. So after you move this, imagine that I have already done with correcting this bug, I would move to design and then I could pass it over to development test so it finally gets implemented and done. And this also at the same time that you are doing this, your dashboards will update. So for instance, if I mark this bug as done, if I go back to my summary, I would expect not to see a dashboard telling me that I have bug. So this is completely just, oh, sorry. Here. So I fixed my bugs just by dragging this work item. It'd be great if in real life it looked like that, but it's not. But you get an idea of what you can do with this. So in backlogs, you also see all the tasks that you have in backlog. It's like a place where to see all the backlog items, but you can also switch to epics and feature requests that are in this project.
And also do your sprint planning on the right side of the screen. Yeah.
And for instance, let's get this backlog items again. So we decide that this we use the sprint 3, just drag it here, and we'll go to the sprint 3 plans effort. Will sorry, what happened?
We lost it. Okay, it's back now.
Oh, okay. So I was showing that you can, when you're doing your planning, you can just drag your
Camera.
Oh, camera. Isn't that working? Sharing camera and mic. I think it's working. Sorry about this. So you can drag this to any other sprint if you are planning your project, and this will show you where the tasks are assigned to the sprints that you've planned for the future. And in the sprint tab, you can see further detail for each sprint and its progress. So right now we are looking at sprint 2, and the other ones are past. The sprint 1 was in the past, and sprint 3, 4, and 6 are sprints that are going to happen in the future. So right here, we have the progress of the tasks. So we have the columns that we expect, the to-do, the in progress, and the done. And so this is completely integrated into an agile methodology. Azure Boards also provides you this tab with queries. So, for instance, I would like to know that the state of some work item, or I want a list of any work item that is marked as bugs. Let's do this here just to try it. So I want a work item. The value is bug and the state is any. So I can run this query right here and see all of my work items filtered based on the criteria that I chose up here. And I can save my query for later. So I can use this and share it with my colleagues that are working on this. So when I go here, I already have saved query with my criteria. Okay, so now let's get over to Azure repos. So the Azure repos, in this file section, you see what the content of your repository is. So you can navigate to your file structure to see what the files are currently there. You can even just edit it right here. You can just click a file and you can edit it in the browser instead of using on your development workstation. And so you can just change something here. I'm just doing something that doesn't really have any impact, but just to show you that you can change here, you can commit it and have the commits being associated with your user. In the commits tab, we can see all of the commits that have been done throughout the time. So I just updated the git ignore, it's in progress. But you can see the story of the commits that have been done through the time on your repository and see this merges. So the same kind of feel that if you are using other Git repositories on other solutions, you also have this kind of visual representation of the commits here. Well, in the pushes, we see as expected, the pushes that have been done to the repository. So we have this first one, which is just the push that's associated with the generation of the project. So it's one single push with lots of commits on it. But you can see it here. And in this other one that's running now, it's the file that I just updated previously. In the branches section, you see all the branches of your code. So if you are, for instance, using a master branch, just development and feature branches, you would also see them here and see the author of the branches. Also, you can also see how further behind and ahead related to the master each of the branches is, and how many pull requests you have on either of the branches. So tagging allows you to set a tag for a specific commit. For instance, this one tells me that this commit is related to this version, and so this is a great way of associating a specific commit to a version of your application that you want to ship, and have a clear overview of what commit generated the version that you are working on. So pull requests, Azure Repos also supports pull requests. So this is generated, but it works as expected. You do a new pull request with some code change, and then it will have to be approved or not. And you can have a discussion here, similar to what you see on GitHub with pull requests. You also have this same kind of integration here to manage pull requests throughout the time. Now let's move over to Azure pipelines. So we have something running here. This is the commit that I did. So let's take a look at this pipeline, what it does. So here in the pipelines, you see all the tasks that are part of the build process of the pipeline. So for instance, to do a nugget restore, the solution, compile it, and then do some test assemblies to guarantee that the code is ready for being published. Do some more tests, copying some files, and you publish an artifact, and this published artifact can be used on your release pipeline later to deploy it to your environments. So until this point, there hasn't been any deployments, just the build phase of your project. So ending up with the publishing of an artifact to be used in the release. Now let's get over about environments and deployment groups. I'll talk about these two simultaneously because they are quite similar concepts. Environments only work with virtual machines and Kubernetes for now. And when you create an environment, you will be working with YAML mainly. Environments are a way of creating, separating, for instance, your production environment from your dev and quality assurance environments, and target them in your build and in your release process. So you have groups of virtual machines or Kubernetes namespaces that you can target either for production, pre-production. Depends on the way that you organize your infrastructure. Deployment groups are similar concepts where you create groups of virtual machines, and in this case, deployment groups only works with virtual machines. So you can create groups with the same concepts of pre-deployment, pre-production, quality assurance, whatever you are using, and then group these groups of virtual machines within a deployment group. You can see that what pools you have available and the status of the virtual machines on each of the available pools that you have created. So let's get over to releases. This is where the deployment to your environment should work. Okay, I did something here. We can see that the dev stage is failing, but let's take a look at the pipeline of the release. So as you can see, this artifact can be used as a trigger, the artifact that was published by the build pipeline, and trigger all of these stages with lots of options that you can do it here. So for instance, the release pipeline can start by deploying to dev, then quality, and then production, but you should always have some kind of maybe gate to do not make it pass to production instantly and do some testing in between. And you can have different kinds of tasks for each kind of stages. Let's take a look at the tasks in the dev environment. So these are not completely populated, but the idea here is that this build would create an Azure, for instance, app service and deploy the app service to the dev app service. So releases is the pipeline that you should use to deploy finally to your infrastructure. So on the library tab, we can see all the variables that we have created and to use on our pipelines. For instance, I can create variable groups that group sets of variables to use in pipelines. So let's, for instance, I'm building something and I want to add a version number. I can use variables to do that, or to do some kind of configuration for our application that is dependent on relying on variables to configure the environment. You can do this here and then use this set of variable groups on your pipelines, either in release or in the build stage of your pipeline. It also provides you secure files. Secure files is a way of you storing sensible files like certificates or signing keys, and then you can connect them directly with your pipelines without having the need to have these files stored along with your code, which is a terrible practice, and you should separate them from the rest of your code and not store them in repositories. So this library can help you do that and have a secure environment for build and release. Finally, task groups. Previously, I showed you that either pipelines in the build stage and release have tasks that are chained together to build an environment. But imagine that you are using some tasks that are similar in several pipelines, and you want to use them and repeat the use of them, but not want to configure them every time you are using creating a pipeline. You can create task groups here and centrally manage the tasks that they have inside of the group. And so by doing this, you avoid some work of having repeated tasks spread along your pipelines. And so you have a central part to manage that. Well, let's get over to test plans. So as we talked in the previous presentation, test plans help you test your code. So right here, this is not really populated with anything, but the idea here is that you can do several kinds of tests. You can do load tests, you can do runs to test your code, and you can also do like functional testing for your project. You can create tasks that you give to your users that are responsible for quality assurance of your code. And then they'll have a script that they'll have to follow and just pick whatever is working or not, like a manual functional test. You can also use this in test plans. It doesn't have to be everything automated. You can do this to help your users test your application before they go into production. And finally, artifacts. You can publish your artifacts here to use them along your projects. We've talked about this on the presentation. It's not really populated here, but as we explained, you can share it within your projects and we use them. So, and with this, we finish the overview of the Azure DevOps portal. So I'm going to hand over the word to Pedro, which is going to follow up with an amazing demo.
Okay, Nuno, thank you. Just leave your screen there, for instance, for a moment. Could you press create feed for me? Yeah. Okay. A feed can be created by using public sources like an npm package repository, right? And it can include your own packages for you to use in your projects. Can you click also in pipelines just to clarify some issues that can be confusing? The terminology of Azure DevOps pipelines, this menu option that Nuno is selecting right now, is for continuous integration. So these are build pipelines. Azure calls releases, the other option there. It's the Azure DevOps name for deployment pipelines. Okay, so this can be a little bit confusing at the start. So I thought it could be useful to clarify this. So I'm going to take over the control right now. Okay. For some other demos. Okay. Thanks, Nuno, for the nice overview of Azure DevOps. Now let's go to the fun part. We are going to show you two live demos and actually show you Azure DevOps in action. For the first use case I have here to show to you is a very simple use case where we'll be demonstrating the deployment of a small web application into a single virtual machine. The application was taken from the Microsoft documentation regarding ASP.NET Core with Razor Pages. I have a link in this slide. And the VM is also already configured to host ASP.NET Core applications in IIS with the site already deployed. The VM is also running SQL Server Express with the site database. So the use case I'm going to demonstrate to you is as follows. One of our customers is running this website in Azure VM, and the environment is managed by Claranet. An external supplier provides us with a zip file containing the binary-only version of the site, and there is a new version to be published. We are going to use Azure DevOps here to automate the deployment of this site into the VM. So let's follow the whole process in this slide. First, the supplier uploads the zip with the new version of the website into a blob storage. In the next step, the customer or Claranet starts the continuous the CD pipeline, okay, the continuous deployment pipeline. The pipeline starts by retrieving secrets from Azure Key Vault, which is a service that you can use to store certificates, passwords, and other secrets. And then the pipeline retrieves from the zip blob store, the zip file, zip into. It also replaces the connection string that it was previously stored in the Azure Key Vault. So let's see this in action. I will start by showing you the Azure resources that were created for this demonstration. The blob storage here, okay, in a storage account, then the Azure Key Vault, and then the virtual machine. And also I'll show you the Azure DevOps resources that are involved in this process. The CD pipeline, the release pipeline, like I showed you, like Nuno showed you before, and also the deployment group. Okay, let me switch back to the presentation, to the demo. Okay, so first I'll show you in Azure. In the Azure portal, I'll show you this resource group that was created containing all these resources. The Key Vault only has one secret right now, which is called my app connection string. And if I show you the value that it is stored there, it's the connection string to the SQL Express database, okay? With all the username and password. Next, I will show you the storage account that was created that contains blob storage only. And there is a special container on this storage account called zip packages. And inside this container, there are already two versions of our site. There are two blobs, two zip files that were previously uploaded with the two different versions of the application. Let's suppose this latest version that is here was the version that our supplier just uploaded to this storage account. Now I'm going to show you the virtual machine that was created. It has an associated public IP address and also a DNS name. So I'm going to refresh this page. You see the site that is already published inside the virtual machine. It's a very simple demonstration site with two pages, the home page, which says welcome, privacy page, and then this dynamic page that queries the SQL Express database and retrieves a list of movie titles. So these are the resources that were created in Azure and are already running. I can also remote desktop inside the machine, okay, and show you IIS with the default website. Browse to this default website, and of course it is the site that I was watching in the public IP before. Okay, and then I can explore and show you the site that is published inside C in a www root. Also, as you can see, this site contains only binary files, DLLs, and configuration files. Okay, so there is no source code over here as usual. And there's a special file called appsettings.json that contains the connection string over here, the connection string that it is used to connect to the SQL Express database. Okay, let me go back and now go to the DevOps, Azure DevOps organization, where we have previously created a project called Cloud Activate App. Within this project, we only used those two resources you saw in the slide, so deployment groups and a release pipeline. I'll start by showing you the deployment group that was created. There it is, Cloud Activate Deployment Group. And inside this deployment group, you can already see the VM already registered and online, ready to receive commands from Azure pipeline. In order for this to happen, we have to run this PowerShell script you can see over here, in order to install an agent inside the virtual machine. I'm going to show you the agent running. Go back to the virtual machine, open services. Okay, and here we have the Azure Pipelines agent that is registering this VM into that deployment group. Okay, so now I can use this deployment group as a target for deployment. I'm going to show you the deployment pipeline we have configured here. It's called deploy zip to VM, and I'm going to edit it. This is a special pipeline that has no input artifacts, and there is only one environment called dev. Okay, and inside this environment, there's a deployment group job that targets the deployment group I've just shown you. So all these 4 tasks you see over here are going to be run inside that Azure pipeline agent inside the VM in order to perform what we desire. Okay. So this specific task doesn't run in the agent. This is the first task. Is a task that is connected to the Azure Key Vault service and retrieves all the secrets. We have no filtering here, so it retrieves all the secrets that are stored in the Azure Key Vault and stores them temporarily in variables inside this pipeline. So we can use in the following tasks. And we are using in this task, this is a special task that copies values from the variable that was retrieved from the previous task and creates a new variable called connection strings.razor pages movie context. So the value of this variable is copied to this new variable. Why we are doing this, I will show you a little bit later. But it has something to do with the JSON. Something to do with the JSON file I showed you before. Sorry, I just clicked in the wrong button. The app setting JSON file has a section called connection strings, and inside this section is a setting called razor pages movie context, as you can see. So I'm creating a variable with this name, connection strings dot razor pages movie context. Okay, let me go back to DevOps portal. The next task is a task that these first two tasks don't run in the agent. Inside the virtual machine. And it is a generic PowerShell task that runs a script we have previously stored inside the virtual machine called download zip.ps1. And we pass along to this zip file some arguments with another variable that is defined here in the pipeline. I'm going to show you. Right now it's defined with the value latest, okay? But this zip file, I can show you it running inside the virtual machine. Let me open PowerShell and let me go to Claranet's scripts, and here it is. So let's run download zip with that argument, zip file name, and specify latest. This PowerShell script was developed by us and just connects to the Azure Blob Storage to download the latest version of our application, the zip file with the latest version of our application. As you can see, it's already here, and renames the zip file just to myapp.zip. Okay, just going to delete this, it's no longer needed. So this task runs the PowerShell to download the zip file from blob storage and store it inside the virtual machine. The next and final task is the one that does all the magic. This task deploys the zip file into IIS. It does that automatically. You just have to specify the zip file you want. It's already stored inside a default working directory used by the Azure Pipelines agent inside the virtual machine. And is going to publish to the website named default website. It will also remove from the disk all the files that are not inside this zip file will be removed. So this is an interesting feature, just to avoid leaving files behind, okay, some garbage. And also does this special thing you can see here, take the app offline. So automatically this task will tell IIS to take the application offline for a few seconds while it's replacing all the files, all the website files. The magic part of this task is this variable substitution option. We specify the name of a JSON file, the app setting JSON file, and this task automatically replaces inside the content of JSON file, inside the JSON file, the connection string value with the value that was retrieved in the previous two tasks, the key vault task and the transform value task. So let's see this in motion. I'm going to create a release to publish a new version. Let me check which version exactly is. I can leave with latest. As you can see, the PowerShell script retrieves the latest version automatically if you specify latest. But I'm going to be specific and I'm going to tell them I want to download this zip file from blob storage. So I'm going, for this run, I'm going to say that the variable zip file name is equal to this value. Let's create the release. The release was created and is starting to run, like as you can see here. It was manually triggered, like I explained in the overview slide. So it's running. Okay, let me just refresh over here. It's in progress. Okay, it's already run the first two tasks. It's now downloading the zip. My browser is having some troubles here with refresh. Should refresh this automatically. But if I go back and refresh, I believe you can see. Let's try to refresh this way. Okay. It is. It's already run all the tasks. Okay. It's just succeeded. So if I go to the public URL and go back to home page, you can see the welcome text just changed to welcome to Cloud Activate. This is the only difference between these two versions. Now let's assume that this deployment went wrong and I want to roll back all this that I just made. So I'm going back to this release, previous release, okay, and say redeploy. The deployment queued is in progress. It's running. Now it's working. It's running the download task inside the agent. Now it's deploying to IIS. And just completed. So if I go back to my home page and hit refresh in my browser, I'm back to the previous version. And that's about it. That's why I wanted to demonstrate to you regarding this this use case. So Nuno, I'm going back, switch back to you for another demonstration, now for a more complex use case.
Okay, thank you, Pedro. Okay. So on this second use case, we are going to show you a real production scenario. So this is used for the development of Claranet's Go Cloud Portal. It's also an example of how you can use Azure DevOps and connect it with other cloud providers and services outside of Azure. The scenario is a containerized application that is running on AWS ECS, Elastic Container Service. And so let me try to explain you the steps that this pipeline does. So firstly, the developer will push some code change to Bitbucket. So because we have a service integration between Bitbucket and Azure DevOps, the CI pipeline is triggered automatically. This pipeline creates a new Docker image and pushes it to the container registry on Azure, on AWS, sorry. And with this, the build is completed and the release pipeline is triggered. The release pipeline reconfigures the pre-production ECS environment. So at this stage, we have a working pre-production environment. The next step is that all the configured approver users will receive an email asking them to authorize and to initiate the production release. If one of the users approves this, the pipeline creates a copy of the container registry for production and pushes it to this other ECR, in AWS. The release pipeline reconfigures the production ECS, and then in the end, we'll have our application working in production. So now let's go over the configuration of these pipelines on Azure DevOps, and I'll try to show you this working. Okay, so we have here our project for the Claranet portal. I'm going to go inside of this, and I'm going to navigate to the pipelines. So this application is actually a kind of a microservice application with several modules, and I'm going to focus on the portal model. But before I start this, I want to show you how this integration with AWS and Bitbucket works. So in your project, you can create service connections to external services. So if I navigate to my project settings and look up for service connections, I can see that we have several service connections either to Azure, Terraform, and AWS, AWS connection, and the Bitbucket for the project. Going back to the pipeline to show you the build pipeline, as Pedro explained before, this name pipelines is really referring to the build part of your CI pipeline. So portal. I'm going to focus on the portal. It's the front end, and so I'll be able to show you something that really changes, and you can see it working. I'm going to edit the pipeline and go through all the tasks that are configured on it. So here we are. So this pipeline is triggered, as I showed before, with a commit to the GitHub, to the Bitbucket repository, and it runs on a hosted Ubuntu virtual machine. The first steps is that we are downloading some secure files. In this case, SSL certificates and some keys. And in the previous slides, we showed you that you can view all of the secure files in your library. So if I go here and I check my secure files, I can see that I have some certificates and keys here, and I can, putting them here, I have a secure place to store them and choose which people can have access to them or not in the DevOps environment. I'm going back to the pipeline. Okay, so as I was telling you, the first step is to download an SSL key and an SSL certificate. So as you can have tasks that run scripts, we have added this intermediate task that what it basically does is that it populates the status page of the website with some information about the build definition name and the build number. This is a way of making sure that the version that we are seeing live is the one that is related to the build that we did before. So after changing this file, we copy the downloaded files to the default working directory. And this project is set up in a way that we have the code and the Docker file in the same repo. So when I'm copying files, it's going to copy them to the context of the building of the Docker image. So after copying files, we do an additional step. This already bit us in the net before, so we put a task here that assures us that if you trigger the build will fail if the certificate that it's pulled from the secure files is not valid. This is a way to make sure that you're not pushing to production or pre-production an application with invalid or expired certificates. So if this task is succeeded, we go to the next one, and what it really does is just build Docker image. It doesn't really have many parameters. We are just specifying the image name here. It's the CCMP portal. And after the build process of the image finish, it pushes to the ECR in AWS with the latest image tag. So when this pipeline, build pipeline finishes, it triggers the release pipeline. Let me go over the release pipeline to show you. So we have several things running. We are focusing on the portal. So I'm going to edit this, show you the tasks that are part of the build process of this, the release process of this module. So as you can see, we have two stages here. The first one is pre-production, that makes sure that the pre-production environment is ready for testing, and then we have production. We talked before about the gates, and we have a pre-deployment condition here configured, and this makes sure that when we are publishing something, it doesn't go to production without any of these users going to their emails and click an approval to go to production. The tasks that we have here configured for pre-production are actually quite simple. This is just two steps. I don't know if you're familiar with AWS ECS, but we have task definitions that are responsible for managing several aspects of our containers. And in this point, we are just telling this task definition that we are not using no longer the previous version of the Docker image, but we are using the new one. And we are using to reference this, the build number ID that is generated by Azure DevOps, using a nomenclature that we predefined. So after the task definition is updated, I'm not going to too much detail into this script, but the idea is that we're configuring the task definition to use the new version of the container. And after we guarantee this, we go over to the next stage, that is the running an AWS CLI commands that forces our container cluster to update and use this new image. So I'm going to show you this working. So before we start, I'm going to show you the portal. So it's here. So this is the pre-production portal. The status page that I've showed you before, it's right here. So I can see which version is currently running. It's the build with this ID and the commit that triggered it, and some other status information about the portal. So let's make a small change to the portal to see the pipeline triggered and the build and release pipelines working. So let me get over to my command line. So I'm going to navigate to the repo of the portal, and I'm going to edit file on the front page, on the login page, so we can see that the change is really happening. So sources, use, login blade. We just look for a nice place to do this. It's called activate demo. What? We just should have done a git pull before to make sure that I'm using the latest version. Okay, I am. Okay, so I'm finished done editing my file. You can see that I have some changes. Okay, I'm going to add this file. And then I'm going to commit, activate demo. I'm going to push this. Okay, so we've pushed to our repository on Bitbucket, and we expect that our build pipeline is triggered at this moment. So let's take a look. We can see that it's already running. So here we are seeing every step of the build process. Each of these steps is already run, so the certificate is valid, the files are copied, and now it's starting to build the Docker image to be pushed later on to the repository, to the container registry. But this step right here, it takes a couple of minutes. So the Docker file has lots of steps that he has to go through and pull some other code. So I'm going to show you what I was talking about, the task definition on AWS while this is running. Okay, I already have a tab here. Let me just make sure that I'm logged in. I am. So here we have our repositories, and we can look for the portal to check if everything we've done in the past is here. You can navigate to your images here. It's just to show you that you can navigate through your images throughout the time. And we all have the images tagged with releases, as we showed you in the build of the pipeline. This is really helpful. We'll try to show this later on, but it is really helpful if you want to do a rollback to a specific version. And all of this is matched with what's on Azure DevOps. So it's a great way of making sure that you know what is running, the version of what is running, and helps you just go through the versions back and forward without any issues. So the task definition. I'm going to show you the task definition for the portal. So portal preparation. So what the pipeline is actually doing, or by reconfiguring the task definition, is creating a new revision of the task definition. The task definition describes the configuration of the Docker file, of the container that is running. So what's the command that I showed you before that does a reconfiguration of the task definition, what actually does is just edit this right here. Let me go back and create a new revision just to show you what would happen automatically with using Azure DevOps. The command that I showed you before in the pipeline, what really does is just change this. So the task definition is set to use this version of our container image. And so by using DevOps, it will create a new revision pointing out to the new version. All of this is not changed. The only thing that we are really doing is just inform the task definition. Okay, there's a new version and you should use it. Then when there's a new task definition, the whole process is triggered to set the container running on the cluster. You can see that we have several containers on our development cluster running. I go to portal, we should have one for the portal. We have this version, this revision running, 113. So let's go back to our pipeline build to see how it's doing. Okay, it's still running. It's half of it, I guess. We have a couple of minutes to kill and wait for the build process to finish. We have some elements of our development team here. I hope they don't get mad at me if I break something.
No. Well, we are waiting for this to complete. So in Amazon, we are using a service called ECS, right? Elastic Container Service. It's basically a cluster that can run container. And we have also ECR, container repository. And this pipeline is right now creating a new image to push into that repository.
The build agents, which I showed you before, is locally the Docker file. It's just Docker build. Then when it finished, it will try to push this to the repository in AWS. Yeah.
Okay, so after the image is inside the repository, we have to tell AWS to get that new image and start the container inside the cluster and terminate the previous container, right?
Yeah, so we push the image to the container registry, and that step that I showed before, the compression of test definition, does exactly what you say. It informs the cluster that there's this task for the portal front end has a new revision, and it's using a new version of the container that we have just built. Yeah, so it's almost there. We finished the build process. It took 5 minutes, and now it's pushing to the repository. So it's pushing the difference. It's working as expected. It doesn't push everything, just the differences between the previous image and this one. It's going through all the layers. And it's done. It's finished. So right now the build process is finished, and what we expect is that this by finishing the build process, it would trigger the release pipeline. So let's take a look at the release pipeline for the portal. So right here we can see that the pre-production environment is already in progress, the deployments. Let's take a look at the steps right here. And it should be doing what we talked before. So it's reconfiguring the task definition right now. And then it will force the cluster to refresh its state, for instance, to use this new configuration of the task definition. And the way this works is that when you have a new task definition revision, the Docker image, the container is created a new container besides the previous one. And when the new container is already running, the ECS takes away the older one. So this allows you to transition from one version to another without actually any downtime, because the service is responsible for draining the connections to the previous container and starts pushing them to the new one. So it's a nice way of switching versions of your software if you are using containers or this kind of services, actually. Okay, it's finished. So let me just show you the pipeline again.
You guys are saying that the cloud portal is down.
It's not. I don't believe it. So as we talked before, this task is already running, and we have this gate. So anyone in this list should have received an email to an approval to production. So you guys, if you are seeing this, don't approve it, please. This is just a demo. Let me check my email to see if you have it here. So it's we have several emails. So this one is canceled because the new version is actually fresher than the old one, and the passage of production of the previous version is canceled because now the gate is on this version. So here we have an email. See the content. Okay, so it has some information about what triggered and what release is going to go into pre-production. So any of these users can just click on this view approval and decide or not to approve it. I'm just clicking to show you. So in the users that you have configured here to approval, they don't really have to be developers. They can have a role of stakeholder on your Azure DevOps organization, which doesn't really give them access to your pipelines and to configurations, but it allows them to interact with these approval gates. And so if I click here, approve, it would trigger the deployment to production. Not going to do that. I'm just going to try to show you if this worked or not. We should have something here, Cloud Activate demo. So here we are. The deployment to pre-production worked. But Vasco is here, so he's telling me, no, go back. We don't want this on on our environment. So as Pedro showed in his demo, you can Azure DevOps has some functionality that really allows you to easily switch between versions. So what I'm going to do here is I'm going to roll back. I don't want this release running. So it's pending approval for production, but no one's going to approve this. So I'm going to roll back to the previous version. I think it was this one. Let's see it. Click here on pre-production and I say deploy. So rolling back changes going to an older release. So I'm going to do this, deploy. So because we are using tags in our Docker files and images that are pushed into the repository, it's easy to do this. The DevOps, Azure DevOps has information on the tag of the build, which is matched to the tag that's in the container image. And so this is basically just reconfiguring the task definition as we saw before to use the previous version of the Docker image. While this goes, let me see if I can get this on time. So refresh here. I would like to show you that how this is working. So you can see that you already have 2 portal containers running. So one of them will die. The old one will be killed by the ECS service. Let's see if it's already sending traffic to the previous version. Oh, not yet. And I have to wait for it to kill it. Sometimes this takes a while. It's just a couple of seconds. Maybe he's draining some connections. Just have to wait a little bit for it to kill. You could go there and kill it manually if you want, but we want to see this working automatically, so I'm not going to do that. I'm just going to be patient and wait a little longer. It's still here.
So, no, while we are waiting, how difficult it was to set up Azure DevOps with this environment?
So connecting both environments is quite easy. The service connection that I showed you before is just asking for some kind of authorization. You have to log in, and it will connect both of the services together. The difficult part about this pipeline was mostly the reconfiguration of the task definition to find out the proper way of doing it and integrate it with the DevOps. But the integration itself between the 2 services is it's really easy. It's just service connection that you had. It asks you for the information of the service that you want and asks for credentials. And then if you are authorized to do this kind of connection on your service, it will integrate with DevOps. So it's really easy to do that. This is still running. Yeah.
Demigods are not in our side now.
Yeah, I don't think so. It was quite fast previously. Oh, okay, it's done. It's killed. So let's see if I rolled back to the right version. Actually, I didn't. So we are still seeing Cloud Activate demo because we did a dry run, and so I rolled back to a version that was already had this message here. Let me just check that at least the version that it's running is the one that we wanted. So it's built 16.1. Let me just make sure this is it. Actually, it should be running 15.3. So maybe this is just a refresh problem. Do it again. Maybe I mixed up the versions and used. Oh no, it's not there. So I can just give me a few seconds just to validate. No, it's not Redis cache. This environment is not using. This is why you see that error. to validate which version is currently configured in the task definition. Yeah, so it's working as expected. The task definition is actually 16.1. And we have 16.1 here. No, finally, it took a while to refresh. Just needed me to double check it. So, refresh it. Okay, so it's the demo that I did before without the exclamation mark. This one, it did the rollback. I just didn't choose the oldest that I could have to do this. So, okay, with this, I finished my demo of the Go platform. Maybe I'm gonna hand over to Vasco.
Yeah. So guys, so this is what we wanted to show you. Now, I think it would be nice to open up for questions that you might have. If you don't have questions, I will promise that I will make it to you. So any volunteers that want to talk first?
Hello. Good morning, everyone.
All right. Okay. No one is volunteering.
I did raise my hand. Okay. I did raise my hand. Good morning to everyone, and nice presentation. Congratulations. I do have a question. Early on this presentation, we were told that DevOps was not suitable for large organizations. This was right in the beginning with Pedro Carvalho. Could you please elaborate on that explanation? Because I belong to a large organization and I really would like to know a little bit more about that. Thank you.
Okay. So before I answer, I'm going to ask if any one of my colleagues want to speak on this. Otherwise, I'll do it.
We're getting feedback over here.
Okay. So Rui, what we want to say with that is that DevOps can work on large organizations. It's not suitable for traditional large organizations. So there's the difference there. For instance, with in your organization, you are doing this transformation for quite some while. So we know because we work together, and we know that you have some kind of you have put in place this agile organization that we have shown, where you put operations and developers almost working together with aligned goals, right? So when you do that, it works. What we mean by it's not suitable for large organizations is that for this to work well, you need to split up the teams in smaller teams. So you cannot have a very large team doing this. Otherwise, it's just too complex, because it will raise a lot of communication problems and collaboration problems. So it needs to be, you can implement in a large company, but you need to create smaller teams so it can work. It can work well.
And how would be those boundaries created?
Sorry, we are not hearing you. Well, I'm not hearing you.
And what would be those boundaries criteria? What do I need to? Okay, I have a big team. Let's say a big application team. I have a big operations team. How would I divide those teams? I mean, what would be the boundaries criteria? Is there any applicable or recommended practices for that?
Yeah, there's not a right or wrong answer. It's up to it's up the way. It's usually it's up to the application that you are developing. Let's imagine that you are developing a small application, a very small application, like for credit insurance, something like that. So in those cases, you should implement a small team, the developers and 2 or 3 guys from operations and the guys from quality working together on that application itself. So the whole team will develop that application, all right? But when you have very large applications, typically you can divide the teams by features. So we have, let's say, our home banking application. So it's a web application, very large, where you have a lot of different features. You have let's say simulators for credit approval. You have your account balance. You have all different products. Well, in those cases, you should divide the team by functionalities or by products, right? So everyone is focused and aligned on that. This way, when you are doing a deploy for, let's say, a simulator for risk management or something like that, you can do it by your own. The team can work on its own and do the release and deployment without affecting the work that is being done with other guys. So no one should be waiting for you cannot deploy because I'm still not developing the code on my side. So everyone should have the freedom to do deploys as much as they want. This is something that we see often, right? So, but there's no right or wrong answer.
Okay, thank you.
Right. So Pedro, go ahead.
Okay. Hi, Vasco. Good morning. So picking up on what Rui just said, we are working on a new platform from the last year. We are using Azure DevOps from idea to production to handle all of the life cycle. And we are also changing our mindsets. We also have these small multifunctional teams working on features, and we are facing the same dilemma, okay? Picking up on what you just said too, there's no right or wrong way to do this, but what we did was when we delivered the first releases of the platform, of this new platform built with this in this mode, okay? What we did was for stabilizing the platform, we mingled people from the development into the product operations team, okay? So that they can do a handover and, well, introduce them to the new architecture concepts and so on, and to the new platform, okay? I don't know if that would help Rui or not. We are now facing a different error because we have two platforms living and coexisting. We have a huge monolithic application, and we have a new platform based on microservices, and we have a splitted product operations team, okay? I was wondering if you know, or if you have some sort of advice on how to keep up with this change, how to keep up with this mind shift, okay? Because now we have an operations team of 17 people, for instance, or 15 people, and some of them are working on the new paradigm, and some of them have to keep ensuring that the old platform still runs and it's still existing. How long, from your expertise, how long would this on average would this shift take, and are any other different approaches to do that?
Well, one thing that we learned based on our experience, and keep in mind that we are not developers. We are operation guys that are implementing DevOps to help our customers be more agile. So we cannot develop the code by you, but we can help you be more agile and more fast on doing your deployments. But based on what we have seen in other customers, it really depends on how the organization is looking at this, because it needs to have a very strong sponsorship from C-level to say, let's kill this monolithic app because it's slowing us down. I assume that you are having more problems with a monolithic application than with a newer one, but that is based on microservices. So I would say you should kill the monolithic app as soon as you can, but we know this is more easier to say than do. So what we have seen in other customers is that instead of just refactoring completely the application, they view it by modules. So you have a monolithic app with 10 different features or functionalities. Break down each one of the functionalities and move it to the new architecture based on microservices or serverless, the architecture that, and find a way to monolithic app. So you can, if you do this step by step, you are going to get into a point that the monolithic app doesn't longer exist because everything was migrated to the new architecture. This could, of course, obviously could take a lot of time, but it really depends on how much keen your organization is able to do that, because it needs to invest resources on doing this refactoring feature by feature. It can take a while, but if you are focused on that, you should be, you could improve the speed of doing that by putting more resources. But I'm pretty sure that the mid and the long way, you are going to have a lot of benefits on that, not just on the operational side, but on the business side, because you're going to be able to respond much more faster to the business needs. This is what we have seen.
Okay. Thank you, Vasco. We already see the benefits, okay? So for the new platform, we are shipping software to production on a daily basis, okay? So we already see the benefits. And the strategic goal is what you just said, is to kill the monolith, but we need time to get to the final objective, okay? But that's the approach. Thank you.
Break it down in parts, and it's easier.
Yes, that's what we are doing. We are slicing, as the good old Portuguese say, we are slicing the elephant, okay? I just have one question, okay, regarding Azure DevOps, okay? We are using it for almost 2 years now, but we would like to know what extensions do you suggest for the Azure DevOps marketplace to generate reports and on progress, bug control of all of the data that we are feeding in Azure DevOps right now?
Mm-hmm. Okay, so without trying, I promise that I will, in the beginning of the session, that I will not try to sell you anything. But we actually have a very cool product for that, which is called Code Patrol, and this is based on the Checkmarks engine, and what it allows to do is detect vulnerability issues on the code before even putting in pre-production environments or testing environments. So this is something that we can do, but there's a lot of different softwares that are able to do that. But instead of just being me answering that, maybe I can ask Pedro or Nuno if they want to put some information here, or even I think Ricardo Fiel from Microsoft is on the call. Maybe Ricardo can answer that, but
Vasco, just to make sure we understand each other, I'm not talking about ensuring for the code quality and so on, because we are already using SonarQube, okay? I'm talking about reports extension. I want to keep track of the bugs that I have, the progress of the user stories, the planning, and so on.
Okay, but why integrate that with why don't you integrate? We actually do it integrated with Jira or ServiceNow in our case, but I think you can use something like that. What kind of ITSM tool that you're using right now?
What kind of, sorry?
The ITSM tool. What is the tool that your developers and your operations guys use to work on every day to report issues, or what are you using today?
Azure DevOps. We use it from idea to production.
Okay, so you have everything there.
Yes, we have all of the data is fed into Azure DevOps. Now I would like to extract it on a structured way. I want to keep up with the bugs evolution. I want to keep up with the progress of the development in the user stories. I want to know how many deployments have I done into production in the last 2 weeks, and those kinds of reports. Okay.
Okay.
If you can suggest anything.
I don't have an answer for you, but I'll go into that, and I will get back to you with an answer shortly. Right.
Vasco, just you were asking if I was still here. I am.
Hey, Ricardo.
Many congratulations for the for the webinar. Unfortunately, I have to go in about 2 minutes. But this was really, really good. And about the marketplace that Pedro was just asking about, there's around 308 extensions just for Azure boards on the marketplace. And the dashboards also have quite a few of widgets that you can use for that. And on top, if you want to do, you know, the deeper dive into analytics, you can export into Power BI or something like that. To Power BI, it's a direct export. So there's 3 options there: marketplace, lots of extensions. Just look for the ones that do what you want to do: dashboard, widgets, and Power BI.
Thank you, Ricardo. We will have a look into the Power BI integration, and I will get a suggestion from you of the 3 top extensions so that we don't have to try all of the 300, okay?
Ricardo, we need to go to do a demo to Portal.
Let's go. Let's go and do it. Yeah.
So I'm sorry because I'm breaking our promise. So we are actually selling something. So, all right. Okay. So thank you, Pedro. Rui, you want to say something?
Well, about extensions, I don't have one question. I have a bunch of questions. Actually, I have a bunch of questions of everything because I'm really diving into this DevOps culture and Azure DevOps tools. So, and I really appreciate this kind of presentations. But I do have a lot of questions, but not really something specific right now. But for instance, for this management reporting, it's really hard to have an extension for a nice Gantt chart for to see we can really manage capacity in a simple way in DevOps, but we cannot manage, for example, how much time did our collaborators spent on this or on that because the task can get it done, and we really don't know how much time did they spend on that. Because when we do when we put a product backup, a product backlog, PBI work item, we just give them, you have 10 hours, for example, for effort. They spent the effort, and we actually don't know how much effort they really spent on that. They just get it done, and that's about it. There is lots of things that is missing. And when you go to extensions on Azure, you can find some of them which they're really that nice. They are not really that nice, and some others you really have to pay, and some others you have to pay, but you don't know how much, because you actually contact the supplier for that extension, they just don't answer you or something like that. It's kind of tough, but it's a really it's being nice. It's being nice. I'm getting much more with Azure DevOps than what I really had before.
Yeah. So and picking up on that way, that's one of the reasons why we are also shifting almost everything inside to Azure DevOps. So currently we work with Azure DevOps integrated with third-party tools, but we already seen that inside Azure DevOps, it's a lot of features that we could be using that do exactly the same thing. So so we are actually migrating more and more things into Azure DevOps. But Azure DevOps is not the answer for everything, and that's why sometimes it's very tricky to integrate with other tools that do or present information that we want to achieve. Yeah, it's something that's not there's not a clear answer on that today. So we need to try the different. Sometimes we need to develop our own tools and integrate with Azure DevOps. But we think that is going to improve and get better in the future. Yeah, honestly, and we have been seeing that happening in the last 2 years. It's much better. Azure DevOps and the tools and the marketplace that is around Azure DevOps, it's much higher now and with much more quality than it was before. Yeah, absolutely. I would like to ask into the guys out here that are not from Claranet, so customers or even other invited people that are here, what from 0 to 10, and 10 being everything automated and you have a very agile and organization, how is your organizations using this DevOps culture? I'm not talking about the tools. You cannot, I'm not asking you if you are using Azure DevOps, because you can use different tools, but are you an agile organization? Someone wants to answer on that? If someone doesn't answer, I will ask directly, I promise.
I don't want to monopolize this session, but please, everyone, just contribute for this, because we're all learning from everybody.
You should shut up. You said the Gantt word.
Guys, no, not guns. No. I mean, we are using Azure DevOps as a DevOps culture. We are not really there, because we have to do a lot of transformation, mentality transformation, and we're doing our steps. But from 1 to 10, some people here are like an 8 or 9, and some others are in 1 or 2. So it's really it's really tough when we have this this delta between this mentality. So we're getting there.
It's actually good that you mentioned that some teams are in the 8 and sometimes some other teams are in 2 inside the same organization, and we call this a hybrid mode. We call it mode 1 or mode 2. So mode 1 is sysops oriented. It's the traditional dev and ops teams. They are working separately with different goals, with different strategies. The dev team wants to deploy faster. The operation team wants deploys to be slower with more stability, because they don't want to break things. But when you go to mode 2, which is DevOps, which is agile, the dev and the ops teams doesn't exist anymore. There's one team that has developers and ops guys, and they both work for the same goal, which is faster deploys with security and stability. So this is a hybrid, and it's very common to see this in larger organizations. Yeah, very common to see that. Only, let's say, a startup that just landed in the last 5 years is working on mode 2, because when you go to the traditional enterprise market, you'll find most of the examples they work in mode 1, and some of them are trying to move to mode 2, and they start with new applications. They usually start with, we need a new application, let's work in a different way. And then we create this application that is going to replace some of the traditional or monolithic applications. So this is sometimes the way we see the transitioning happening.
Vasco, if I can challenge Marco Pereira, he's here, I think, in the call. I would like him to say from his own words or his own numbers, what is the level of automation that we have on our monolithic application, and what's the level of automation that we have in the new application. And as I said earlier, we are in the middle of the journey, okay? Mark, are you there?
He ran away.
He will answer it later, okay? But I would like to see, because he's the head of release management, okay? So he knows the two realities. And I think it would be nice from him to give two numbers of the two different levels of automation that we are experiencing in Vortal.
Pedro, I could help a little bit. Your organization already uses some level of automation with a monolithic application. You use Jenkins, and you have deployment servers to do part of the work. But I don't think it's quite like what you are using right now with Azure DevOps and with your new containerized application. It's much more automated and much more easy to publish new versions on a daily basis, like you say.
I would say 4 and 8, but I would like Mark to say the number.
Yeah. Probably it's probably that. And there's that issue I talked about in my presentation about immutable infrastructure. When you work with containers, you are naturally in an immutable infrastructure world. The container itself, it has everything it needs to run. Okay, so you don't need to reconfigure anything in your servers to run the containers. The containers are already ready to run. So that's a very different approach, like we used in the monolithic applications. Even that demonstration I did, where I published a zip file inside an IIS machine, the machine was already pre-configured, and the site was considered kind of immutable, since I delete the previous version and I replace it with a new version, all old files. I don't keep any state between one version and another. Of course, IIS was previous configured. Of course, we have a SQL database there, so that part needs to stay between releases. But that's the main difference in this kind of approaches when working with mutable and immutable infrastructures.
Hey, Rui?
When we're talking about if our company is in this level 1 to 10 level, in which level they are really actually, we are not talking about technology only. We're talking about processes and people, and we are talking about a bunch of stakeholders like the business relationship managers, security. We are talking about applications. We are talking about infrastructure operations team. We're talking about logistics. We're talking about lots of people, lots of functions. And the thing is, it's not just the technical part of it. It's not just the application, that application that is going to change this organization. It's really a culture, and the culture has to go wider, has to go to the whole organization. And the difficult part of it is really having a whole organization going through this DevOps culture. No, not Azure DevOps or technology or Kubernetes or Docker's containerization and stuff like that. The hard part of it is really having the whole people working on the same basis. And we are not. We are doing lots of efforts to get there, but we're not all in the same level. So just to explain a little bit more why I said that some people are in 1 or 2, level 2, or some others are on level 8, level 9. So the whole organization probably, if we go by average, maybe 4, maybe 5. Okay. Thank you.
Unmute, yes. And that's why I'm trying to share my screen here. And sorry. That's why whoa, it's not this one. Here, okay. Hopefully you can see my slide here. That's why we say that in DevOps, this is not just installing some tools Azure DevOps or Code Pipeline or Jira or Git or GitHub or whatever you want. It's about the hardest process on that is changing minds. Change people here you see it's heavier on this side because this is the part, not this one here, not the tools, it's the people and practices. And we actually have done a project for a company in Portugal, and they are actually shifting from mode 1 to 2, and they asked some help on how they could do this. And we in the end, we have we have presented them 10 recommendations. And the last one was from the silhouette organization to the one that we have mentioned in the next slide that I'm trying to show. Sorry, yeah, this one here, which is, this is the difficult thing to do. And this should move. Well, it's actually breaking this pyramid organization where we have different silos. It's organization where you create cross-functional teams. So this is not a tool that you install. This is people. This is the practices. This is changing the way you work. And this is very tough to do on a large scale environment. That's why we have said that it's not really suited for large organizations because of that. It's not impossible, but it's more difficult to achieve. Yeah, but thanks, Rui.
No problem. Thank you.
So, guys, what about infrastructure as code? Are you using it? Are you using some kind of, when you deploy infrastructure, are you already using infrastructure? Are you already moving from EAS to serverless or PaaS? What about immutable versus mutable infrastructure? Something that it's on your mindset or already or not? So I don't have answers on that. Okay. So
well, I can answer that, but once again,
ahead,
it's me again.
No problem.
It's me again. Everyone is probably laughing out there, but please come in. We are using infrastructure as code. We actually create two Azure DevOps projects, one for applications and the other one for infrastructure as code. So everything related to infrastructure, especially infrastructure as code, is in one Azure DevOps project, and everything related to applications, let's say build pipelines, are in the other project. We actually have a bunch of application projects. Actually, each application has its own Azure DevOps project, but we are migrating the whole thing to two projects for now. So we are still segregated. We are still having infrastructure operations people separated from application people, the development people. So we are not there, but we are walking towards to that goal. So, but for now, it's a it was really nice in August this year, knowing that the next step is having two projects for now, one for infrastructure and the other one for applications, infrastructure with infrastructure as code.
Okay, Rui, what are why are you doing that? What are the benefits you have seen by moving to infrastructure as code? Because you are doing it for a reason, right?
Why don't you tell me?
I know the answer, but I want you to explain it to the other guys in the room. Yeah.
Well, it's less errors, some feeling of the configuration remains remains as we left. There's lots of advantages. I don't know all of them by heart, and I'm not prepared to to for this public to tell all the advantage of it. But there are too many. But it's really it's this feeling of confidence that infrastructure as code bring to us that that is nice, really nice to have.
Yeah, and I can add, actually, I can add something on top of that. For instance, tagging. When you use infrastructure as code, it's much more easier to put in place some governance. One of them is tags, use tags, and actually this, for instance, in some scenarios, allows us to identify which resource is used by which application, and also when you use tagging in all of your infrastructure, when someone goes into, let's say, with AWS or Azure or Google portal and deploys any piece of infrastructure, if it does manually without using infrastructure as code, you can actually detect that piece of infrastructure is not using any kind of tag. And you can also apply a policy that removes anything that has the policies or the tags that you identified. So that's just one example. There is a lot of benefits in using the kind of approach. Yeah, thank you. This is going to be a quarterly webinar that we are going to do. And as I said, this is from our tech guys to tech guys. So it's not a sales event. It's just an event where we want to share, but also learn what you are doing in your organizations. And because we think by sharing, by creating this community where we can share and learn, it will enable us all, not just Claranet, but everyone, to become more agile, faster, and deploy our applications with less risk and with and more safety. In the end, it's all about that. So thank you all for being here.